I'd like to welcome everyone. I cannot see anyone. Can you hear me? And I cannot hear anyone. Are you able to mute or unmute? Okay, so it says just the chat. Okay, well, welcome. I am Heather McDonald. I am privileged to be the secondary NGSS TOSA for Riverside Unified School District. And today I'm presenting on phenomena. I want to thank you all for joining. What I'm going to do is share my screen, and then this will be a way for us to interact, because I am going to start with a pair deck. And so what I would like you to do is to go to joinpd.com and enter the code for our pair deck, AOA TBA, please. The code is on the screen, AOA TBA, and go to joinpd.com. It's through Google. It is not through PowerPoint. It is through Google. If you don't have Google access, you can watch the screen and follow along. Okay. Okay, so this is our presentation. We are phenomenal. We are going to talk about using phenomena in NGSS lessons. And the objectives of this hour-long presentation is for you to experience NGSS phenomena, explain how to effectively use phenomena in the classroom, and differentiate between topic-based lessons versus phenomena-based lessons. Okay, so let's start with this image. I'd like you to take a moment and look at this image. And what do you notice? What do you wonder? And would you please type a response, just one thing you notice or wonder, into your pair deck. Okay, so let's take a look at some of our responses. How do the muscles affect the pipe's function? I wonder how the pipe was covered so quickly. I wonder how many muscles are on there. Is the mussel an invasive species? Excellent question. Growth on tubes. I noticed that the pipe at 6 months is covered with mussels. What would it look like after 1 year? Excellent question. There are a lot more mussels in 6 months than in 2 months. Also fantastic. I wonder how these mussels get cleaned from the pipes. I wonder what they smell like. I'm thinking not good. That's what I'm thinking. I noticed that the mussels reproduced a great deal over 6 months. Yes. What is growing on the pipes? I noticed a large buildup of muscles on the pipe over time. What happened to the last pipe and why did it happen so fast? Clean on the left, but covered on the right. And those are our responses. Okay. So those are all fascinating. And all I did was take an image and asked you what you noticed and what you wondered. And this is a very easy way to get kids interested in phenomena, because essentially this is a phenomena. How does a pipe go from being completely clean to covered in 6 months? And if you didn't notice before, it does say these are quagga mussels on an ABS pipe. So we're specifically looking at one species of mussel. Now, I wanted to show you that because quagga mussels are a very real and big problem. But I also really want to direct your attention to our real phenomenon. So if you could go to the bit.ly, so it's bit.ly dash and then quagga map all in caps so that you can be able to open and see this document larger. And basically it's a quagga and zebra mussel sightings and distribution in California for 10 years through 2017. Take a few minutes to make observations of the map that you're looking at, and then record one of your observations in Pear Deck. I'll give you a couple minutes. Okay, if you're having trouble opening the bit.ly, I'll open it. And then here's a kind of zoomed in version. So at the top, these are all the locations in order by date of sightings of quagga and zebra mussels in the state of California. And as I scroll down, we can see that zebra mussels have been sighted in the San Benito County. And then down here, all of these are quagga mussel sightings in Southern California. So hopefully that'll help. Okay, let's take a look at some of our responses. I noticed the mussels are sighted heavily near the coast in San Diego and appear less often farther north along the coast. Yes. These are freshwater mussels because they're not all found in the ocean. They're found inland. Yes. They appear to be more quagga than zebra. Absolutely. I noticed that the quagga mussel appear near the coast of Southern California, may also be moving outwards. The mussels seem to be more prevalent in areas where possible boat owners live. That's fantastic. The mussels appear in both river and coastal areas. There are a lot more quagga mussels in SoCal and hardly any zebra in NorCal. And one coming in, are there related saltwater mussels that cause issues? It's coming in as I'm trying to read it, in the ocean. Okay. So those are all really good observations and a couple of inferences as well, kind of evaluating the map. Now I'd like you to think about this map that you're looking at, and now I want you to take a look at this map. So again, there's another bit.ly, bit.ly Montana map, and take a look at this map and then record an observation in Pear Deck, and I'll open it again for those having trouble. So basically what we're looking at here is that in the state of Montana, let me back up a little bit. In the state of Montana, all of the yellow represent inspection stations, and all of the green dots represent a postal code of a watercraft that visited the state of Montana. So make some observations and please record one in Pear Deck. And you can absolutely be considering the quagga and zebra mussel map as well. Okay, let's take a look at some of our responses. Super spreaders, what a great response. Large concentration of species on the West Coast. Lots of people love visiting Montana to go to the lakes, go on the lakes with their own boats from all across the US. Inference is that invasive mussels are being transported to Montana. Visitors to Montana are extremely widespread. That's fantastic observation. A lot of people take their boats to Montana. Montana has a lot of inspection stations. Good. Okay. So now I'd like to think about these two pieces. So looking at Montana, and I don't have a map like this of California. Montana does a fantastic job of monitoring watercraft in and out of the state. But it looks to me as though people from all over the country and Canada are taking their watercrafts to Montana to visit, and then they take them back home again. And if you look, it's widespread throughout California. So lots of people from Northern California, lots of people from Southern California are visiting. And yet, and we have to assume that these people are visiting Montana, they're going in the lakes. They may be taking mussels there or picking mussels up from lakes in Montana and then bringing them back to California, and then using their watercraft in California lakes and rivers. And so thinking about that and thinking about our California distribution of quagga and zebra mussel sightings, do you notice anything interesting, and you can type in the chat. They spread and grow quickly, okay? So here's a question that I have. Why are the quagga and zebra mussels not established in Central and Northern California despite a strong presence in Southern California? Given the data that watercraft are visiting all over the country and going from at least California to Montana and back again, and yet we still do not have quagga and zebra mussels in large quantities in Central and Northern California. And so this would be the real phenomenon of what I want to demonstrate. This is a phenomenon. How is it that these are not established? And so this then becomes our problem to solve, okay? And so what I want to do is I want to shift from looking at experiencing our phenomena to actually talking about what are phenomena, okay? So let's talk about what phenomena are, and then let's talk about what it's not, okay? Phenomena are an observable event. So either in need of explanation or understanding, or a problem to be solved using science. Now, one of these is the work of scientists, and one of these is the work of engineers, because both scientists and engineers use phenomena to drive their research and understanding. So you should have a red and green dot on your screens. And what I'd like you to do is I'd like you to drag the red dot. So phenomena as an observable event in need of explanation or understanding is that the work of scientists or engineers. Drag your dot to the appropriate word. And then the green dot, an observable event that is a problem to be solved using science, is that the work of scientists or engineers? I'm just going to give you about 10 seconds. Okay, so let's take a look. Okay, so most people agree that scientists, their work involves an observable event in need of explanation or understanding. That's correct. And engineers use phenomena as a problem to be solved using science. That's correct. So the red dot is the scientist's work. The green dot is the engineer's work. Good job. Okay, let's talk about what phenomena are not. Phenomena are not science concepts. It's not the periodic table. It's not photosynthesis. It's not a simple concept to be learned. They are not recalled facts. It's not a list of vocabulary terms. And most importantly, phenomena are not add-ons to the science unit. More often than not, I hear teachers say, well, I wanted to do a phenomenon, but I had no place to fit it in. It's not meant to be an add-on. Instead, let's take a look at what I'm going to do is direct you to a Jamboard. And I split it up thinking that there would be quite a lot of people just in case. But I think that there's enough of us that we could all be on one Jamboard. So if you just go to the first one, which is bit.ly phenom jam, and that will open, the Jamboard is going to look like this. And we're going to complete activity 1, which is on slide number 2. So if you just scroll here, and one of the fantastic things about Jamboard is that if I click this little arrow to expand the frame, I can see here where my participants are. So right now, once you join, please go to slide 2. And then I would like you to work together and sort these scenarios. So the scenarios that you see, would that be a phenomena-centered classroom, or would that be in a traditional classroom? So thinking about what phenomena are and what they're not, go ahead and move the pieces. Okay, in our chat box, can you please type whether you agree with this, agree with what's here, or if not, and that way I know that you're finished. If not, you're still welcome to move things. Okay, I got an agree. Oh, lots of agreement. Okay, so let's take a look. So phenomena-centered classrooms. The phenomena drives the unit. Students repeatedly return to the phenomena by adding new information learned and how it connects. Yes, sense making is key. Students compare ideas, not to identify what is right or wrong, but rather to encourage conversations and understanding. Yes. The classroom is student-centered rather than teacher-centered. Yes. Students are figuring out phenomena through modeling, experimentation, and collaboration. Yes. Students are encouraged when they make mistakes to revise ideas and or change their thinking. Yes. Phenomena-centered classrooms provide a safe place for students to make mistakes. And a picture at the bottom, the teacher asks clarifying questions as students conduct investigations themselves. Yes, all of those are correct. Versus a traditional classroom, students conduct experiments and or activities with one pre-planned outcome. That is not a phenomena-centered classroom. The teacher provides the knowledge by handing it out at appropriate times and explaining what it's all about. That is not a phenomena-centered classroom. Students fill out worksheets and read textbooks and summarize phenomena to explain them. Having students read about phenomena and then summarize it is not a phenomena-centered classroom. Phenomena are demonstrated once or twice as something cool to show students. Those are not phenomena, those are demonstrations, and they are useful and they can be used in a phenomena-centered classroom, but they do not define a phenomena-centered classroom. Picture of the teacher demonstrating a phenomena and then students repeating it on their own is not a phenomena-centered classroom. And vocabulary is introduced at the beginning of the lesson, and then students make flashcards, so on and so forth. So, very good. All right, so we have an understanding of what phenomena is and what it isn't. So coming back here, let's talk about now, how do you choose it? Because I think this is probably the question I get the most is, what do I pick? How do I know what is a phenomenon, what I'm doing? And so really, the word phenomena encompasses so many things that when you are choosing phenomena, and I will give you some resources to narrow down your search, you really want to be thinking about these 3 things first and foremost. The first is, are you looking at an anchor phenomenon or an investigative phenomenon? We'll get into that in a second. Is what you want to present student-centered, and is it relevant and authentic? So let's take a look first at authentic or anchor phenomena. So here is the definition of anchor phenomena. And what I'd like you to do is I'd like you to underline or highlight or circle the pieces from this definition that you feel best describe an anchor phenomenon. So they form the basis of the unit. They are expected to be complex and observable, and they cannot be answered with one activity or experiment. I'll give you about a minute. Okay, let's take a look. Complex, observable real-life events, question to be answered or problem to be solved, cannot be answered in one activity. Okay. Oops. Oh, there we go. Sorry, I couldn't figure that out. Form the basis for the unit, observable real-life events, question to be answered or problem to be solved. Basis for the unit, complex, observable, real life, question to be answered, problem to be solved, cannot be answered in one activity. Real life events, basis for the unit, I'm seeing some commonalities, right? Complex, observable, real life events. Okay. Awesome. So I think we are in agreement, and I cannot stress enough that your anchor phenomenon drives your unit. It is the basis for everything else that you start, and I'll talk a little bit more about that in a moment. Okay, here is the definition for investigative phenomenon. So I'd like you to do the same thing again. Highlight, underline, circle the parts of this definition that you think best define what is investigative phenomenon. So investigative phenomenon, they support your anchor phenomenon through more bite-sized observable activities, right? They are the concepts that help explain your anchor are taught using investigative phenomena. So in turn, you have several investigative phenomena in one unit that help students understand the anchor phenomena. I'll give you about 30 seconds. Okay, let's take a look. Support the anchor phenomenon. They are activities that explain the anchor phenomenon. Great. Support is underlined, bite-sized observable activities. Taught, build understanding of the anchor phenomenon. Good. Bite-sized observable activities, several investigative phenomenon together. Great. Support the anchor phenomenon. Several together, build understanding. Good. Explain the anchor, build understanding. Good. Bite-sized observable activities, explain the anchor phenomenon that help. Good. Bite-sized observable activities, science concepts, explain the phenomenon, several taught together to build understanding. Wonderful. Again, we're seeing overlap of the important parts of an investigative phenomenon. So again, these support your anchor phenomenon. Okay. So that was the first criteria for choosing phenomenon. The second one is student-centered. And this is probably one of the most difficult for some teachers because choosing good phenomena for the classroom to build the basis of your units involves it being student-centered. And it involves students having the freedom to create their own ideas and make mistakes and work together collaboratively and revise their thinking. It's okay if they don't know something the first time it's explained, right? As you continue to build investigative phenomena, students build that foundation of knowledge and they better understand rather than seeing it once and then moving on. And so I have this quote from Grace Hopper, and she says, the most dangerous phrase in the language is, we've always done it this way. So it may feel very comfortable to be the guide in the classroom. My suggestion is to be the guide and not the sage. Let students drive the learning. Okay, and finally, you want your phenomena to be relevant and authentic. So close to home phenomena help students make sense of their communities and their environments. I chose the quagga mussel phenomenon because it is an issue in Southern California, and I work through Riverside Unified, and this is a close to home problem. It also allows students to use prior knowledge. So if students are familiar with going to lakes or rivers, or even seeing lakes or rivers nearby their homes, then this could definitely pique their interest. This is not to say that world issues may not be relevant, because they absolutely can be. Just you want to make sure that they are authentic. Okay, so we're going to go back to our Jamboard. And again, we just go to the first one, bit.ly Phenom Jam, and we're now going to do our second activity. And so this one is definitely going to take some collaboration. Oh, someone already did it. Okay, so the purpose of this second activity is to organize the cards that are here. And actually, I'm going to move them back because I want you to experience. And I'm not even looking to see if they are correct or incorrect. I'm just moving them. Okay, what I would like you to do is to work together, and I know that is a little bit difficult because you cannot speak to each other. However, what I would like you to do is to sort these so that horizontally they match. So, for example, this first phenomenon, students are introduced to a young girl with a life-threatening infection. So this is a phenomenon. I'd like you to find the topic, right, that matches that phenomenon, and then that'll go in this box. I'm not saying it's this one, but that'll go in this box. And then which performance expectation do you think that matches? So actually, I'm going to apologize to whoever moved these. Thank you for moving them. I see why you did that, so that it can be read there. I will put the phenomenon there. And so go ahead and read through them and then move the topic base into the correct boxes and the performance expectations into the correct boxes. I'll give you a few minutes. Good. Okay, could you type in the chat agree when you feel that you're done, or if you still need to move some things, that's fine. Okay, I will say that there's one topic-based example and one performance expectation for each phenomena. So they do not overlap boxes. Okay, do you agree with this placement? Okay, I have 2 agrees. Okay, I'm going to say that you are likely finished organizing these and that you agree with their placements. So I want to talk about the top one. Just start with the top one. So let's look at the topic first. Students observe a wave model and label the parts. They use the model to collect data and then mathematically identify the relationship between frequency, wavelength, and amplitude. While that may be interesting for some students, knowing the parts of a wave, it is absolutely more authentic to connect a model of a wave to an earthquake. And so our phenomenon, students watch a video of an office experience an earthquake. However, the people in the video seem to know that an earthquake is occurring before the visible shaking is noted. Students use mathematical models of waves and seismic data to construct explanations of the traits of seismic waves, specifically, hard word to say, P waves and S waves. Students use the relationships they determine from the data to design an earthquake early warning system. So it's actually very interesting to watch videos of people in an earthquake, and they all seem to get out before you can even see the shaking on the screen. And so how do they know that there is an earthquake happening? How do they know to get out? And so that is a phenomenon that is connected to understanding waves and wave models, because earthquakes are simply mechanical waves in our Earth. And so that's connected to the high school performance expectation: use mathematical representations to support a claim regarding relationships among the frequency, wavelength, and speed of waves traveling in various media. And that would also include electromagnetic waves. However, this would be a good phenomenon to start that unit. And so taking topics that may or may not seem very interesting. I know to us, because we are science teachers, they're all interesting and they're all fascinating. However, to get students really engaged and curious about science, we want them to better understand their world around them. And so starting with a phenomenon and using that to drive your lessons rather than a topic and fitting phenomena around it are really going to help students stay engaged with the lessons. All right, good job on this one. Okay, we're going to go back here. Okay, so I want to talk about coherence flowchart because these really help to connect our anchor to our key concepts. And so we're going to go back to our problem, which is why are the quagga and zebra mussels not established in Central and Northern California despite a strong presence in Southern California? This was our question from the beginning. And so I, as a teacher, would use my anchor. Notice it's at the very top. I would use this anchor phenomenon to drive the rest of my unit. And so I would divide this, actually, I'm going to show you. This one is divided into two parts. Although I'd probably divide it into even more. And each part that it's divided in, I'm going back to part one now. Each part that it's divided in has an investigation question. So I have my anchor, and then I have my investigative phenomenon, which my investigative question is, how are the mussels, which are native to Russia, thriving in California? And so here are the concepts. By the time we get to understanding the investigation question, here are the concepts I want students to understand. That within a population, organisms are always being born and dying. Non-native species do not have the same environmental pressures that natives do. And when more births occur, the population will increase, which can change the stability of the system. And so we would use our investigation question, how are the mussels thriving in California when they're not native to California, to understand these key concepts. Notice that having solved this investigation question does not solve our anchor phenomenon. It's a piece that we need to understand to be able to understand our anchor phenomenon. And so once we then go to our second investigation question. Notice still our anchor phenomenon is the same. It has not changed. Okay. In our second investigation question, how are the mussels able to increase their populations only in specific areas of California? So the first question was, how are they able to thrive in California in the first place? The second question is, why are they in only these specific areas of California and not throughout the state? And so again, our key concepts, which drive this, help to understand this question. Organisms need to release energy from energy storage molecules in order to reproduce. Organisms get energy storage molecules by consuming other organisms. And environmental changes such as temperature, pH, and calcium levels may or may not affect mussel populations. And so this, I want to actually give you some more information now, looking at our anchor phenomenon. Okay, and if we were in the classroom, we would be in our second investigation question, still thinking about why the mussels are only in a certain place. And I'm now presenting you with some more information. And so this is from the California Department of Fish and Wildlife. And basically, they have this kind of basic map, which shows that zone 1, which is in green, is unsuitable for the mussels. Zone 2 may support the mussels, and zone 3 is definitely capable of supporting mussels. So in the chat box, what hypothesis do you have right now as to why the mussels might be unsuitable for zone 1, but capable of living in zone 3? So you're going to type this one in the chat. This is not a Pear Deck question. So again, the question is, what hypothesis do you have for why the mussels are unsuitable to live in zone 1, which we know our California map supports that they are not there, and yet they are capable of supporting mussels in zone 3, which is Southern California. So I have one hypothesis, climate and weather. Thank you. Weather, thank you. Temperature, thank you. Natural predators, thank you. Less capable of dominating niches in different places. Thank you. Acidity, mineral level in the water. Thank you. Any more? Okay, so all good ideas, good reasons for why. So we now know that there are no mussels in Northern California because the area is unsuitable for them. And so it's to figure out why, right? So a lot of you suggested climate and weather and temperature. And I will say those are excellent hypotheses. And to remind you that this mussel is originally native to Russia, and so is very used to living in very cold temperatures. And my first thought was, oh, it must be temperature. It must be too cold in Northern California for summer part of the year for the mussels to thrive. And that is actually not the case because they are from Russia, where they can survive in very, very cold water. So here's another piece of the puzzle that I'd like you to examine. This bit.ly is distribute map, and again in all caps. And there are 3 maps that I'd like you to look at, okay? And take some time and observe the differences between these maps and write down one thing, one observation, or one inference that you notice from comparing these maps and thinking about what we know about our quagga mussel populations. I'll give you a few minutes. And I will open it here. Okay, so just to kind of show you, map 1 are zebra mussel and quagga mussel potential distribution sites based on a calcium threshold of 28 milligrams per liter in the water. So if the calcium in these areas has a threshold of 28 milligrams per liter of water, you can see that the sites vulnerable to colonization are outlined with a black dot, and not vulnerable are outlined with a empty white or a white dot. So that's our first map. Okay. And if I scroll down, looking at map 5, So zebra mussel and quagga mussel potential distribution. This is now based on a calcium threshold of 12 milligrams per liter. Again, potential distribution. The sites vulnerable to colonization by the mussel are indicated again by a black dot, and not vulnerable are indicated by a white dot. And I would like you to know that there were 4 or 3 other maps in between map 1 and map 5 with varying degrees of calcium level or calcium thresholds for the potential distribution. But I felt that these 2 maps are sufficient for you to make observations. And then the last map is the management priority. So where does the California Fish and Wildlife need to put highest priority? Which areas do they need to put highest priority of watching and controlling the quagga mussel? And so that's the last map. Okay, so take another couple minutes and then fill in Pear Deck, 1 observation, 1 inference, something that you can tie together and from what we've discussed about the mussels. Okay, go back to our presentation. I've got 3 responses. I'm going to give you 20 more seconds. All right, let's take a look. Central California is vulnerable with a question mark. They don't do well in higher calcium environments. Absolutely. Potential distribution is based on calcium levels in the water, and if the mussels can tolerate calcium, they will invade more water bodies. Seems like the higher the calcium level, the less the mussel, I'm assuming is mussel population is what I think that's likely to say. Lower calcium levels equals a wider distribution. Yes, 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 yes. Less mussel population, yes. So that essentially is what is going on here, is that it's not temperature, it's not predation, it's not where people are visiting, it is the calcium levels. Studies were done looking at pH, looking at predation, looking at temperature, looking at all of these things, and the only thing that differed was calcium levels, which is actually pretty interesting. And it also makes it a target for how to help control the mussel population. Okay, so there also was a few years ago started the Don't Move a Mussel campaign, which is a law I know definitely in California and Arizona, it is a law that you have to clean, drain, and dry your boat. You have to take out the boat plug, the plug in the back, in order to even cross state lines. and that is to ensure that you are not carrying larvae, which are microscopic, in your boat across state lines and then visiting another water source. Like we saw with the Montana map, people traveling all over the country to visit Montana and then going back to their homes and probably using their watercrafts at homes is how the mussel is easily being spread. But I wanted to give you some resources that you can use. And so this link opens a Google Doc. And they also check your anchor. Thank you, Kathy. Yes, they do. They check to make sure that everything is clean and dry. And so these are all websites that offer different examples of phenomena for you. Some are very good for investigative phenomena. The NGSS storylines and phenomena for NGSS, those are good for anchor phenomena to help you, although they're still building the storylines ones, that they don't have them for every instructional segment for middle school and high school yet, but they are still building them. There are several there that are very, very good and have earned the coveted NGSS design badge. But these are here for you. They are also on, because you still have access to the Jamboard. They are also here, although Jamboard is a very simplified program, and so these are not links, and which is why I made a separate link area. That basically is it. Oh, wanted to connect. Okay, we don't have time for this, so I'm just going to skip to this. So our objectives, we experienced NGSS phenomena, we explained how to use phenomena in the classroom, and we differentiated between topic-based and phenomena-based phenomena. And so for topic-based and phenomena-based lessons. And so I want to thank you. I want to give you a couple minutes. If you had any questions, you could type them in the chat. Or you can contact me at hmcdonald@riversideunified.org. Thank you very much. How can we use the links to the resources you just shared? So I strongly recommend when you are teaching your instructional segment to look at the big picture of the instructional segment and the performance expectations that go along with that. And some of these resources are actually organized by performance expectation, and they will direct you to different examples of phenomenon that you can use in the classroom connected specifically to what you're teaching. And did I share the PowerPoint? No, I did not. This is being recorded, and so you're always welcome to go back and view the recording. Any other questions? Okay, well, I'm going to stop sharing my screen, and I want to say thank you very much again. I'm going to end the recording, and I hope you have a fabulous rest of your day. Thank you.